Good morning to all of you. I welcomes to all in our lecture series on mathematical physics. Today we are going to be start our new unit, that is unit 2, and the overall topic is second order differential equation with variable coefficient and its solution by power series. Okay, and basically this is nothing but this power series is nothing but called as Fournier's method. And in this unit 2 also we are going to discuss about Legendre and Hermite differential equation. And this is I am going to be represent, this is your the so called whole syllabus of your unit 2. And here you can found the singular points and second order linear differential equations, where I underlined that one. Okay, and singularity and Bessel's Laguerre, singularities of Bessel's and Laguerre, and then Legendre and Hermite differential equations. So these things we are going to be discussed in detail. So before we have to start our syllabus, whatever it is given, now it is useful that we have to discuss whatever we have been studied, or how much or what we know from our last semester, or from the first semester, about differential equation, and how we solved those things. Okay, that means before we have to start this topic, we have to just recap our knowledge, whatever we have uh, taken from our first semester regarding differential equation. Okay, and you can say this is our unit lecture series, and this is our lecture number 24, our lecture number 24 24 up to 23 we have been discussed only about unit 1. Okay, so from our first semester we have been studied that the second order linear differential equations, or the second order linear differential equation, has in the general form is d square y by dx square plus px dy by dx plus qxy equal to fx. That is general form. Okay, so if this fx is not equal to 0, then equation number 1 will be called as inhomogeneous equation. Okay, and if fx will be equal to 0, then this equation number 1 will be called as your homogeneous equation. And here px and qx are called as the coefficients. And solutions, next to these things already we have been discussed in detail in our first semester. Just this is, you can say, only the recaps with short discussions. Okay, so the solution of homogeneous second order linear differential equation with constant coefficient, how we done? See, in general, the homogeneous second order linear differential equation with constant coefficient is in the form of this one. This is equation number 2, and here a and b are the constants. Okay, so this can be written in this form: d square by dx square plus a d by dx plus b y equal to 0. You can check your note of your first semester in detail. We have been done, but however here also I done for your better understanding purposes. You have to follow this one also. So this is d square by dx square is considered as d square, and d is considered as d by dx. So it can be written as d square plus ad plus b equal to 0. And also this is equation number 3. Let y equal to e to the power mx. We are trying to find out the solution of this equation number 2. Okay, so let y equal to e to the power mx is the solution of this equation number 2. Then dy by dx, here you have to write is the solution of equation number 2. Let y equal to e to the power mx is the solution of equation number 2. Then dy by dx will be equal to m into e to the power mx, and d square by dx square will be ms square e to the power mx. Right, now dy, or dy you can write m e to the mx d square y equal to ms square e to the mx. Hence the equation number 3 becomes ma square plus am plus b into e to the mx equal to 0, and this will be nothing but, and this equation number 4 will be like a quadratic equation of m, which is called as the characteristics and auxiliary equations. May you can recall, and or you can search your first semester note. Okay, or you have to write. I suggest that you have to write. You pause the video and you have to write. By solving equation number 4, we found m equal to minus b, like this, minus b plus or minus b square minus 4ac by 2a. So if we have to follow this equation number 4, we can found minus a here minus b is a, b is a, and a is 1. Okay, c is b. So here we can write this will be minus a plus or minus a square minus 4b by 2, and the two roots will be m1 and m2, and that means y1 equal to e to the m1x and y2 equal to e to the m2x are two solutions of equation number 2, and the general solution can be found by determining the nature of the two roots of the auxiliary equation. And these possibilities, what are the possibilities? The roots are real and unequal, or the roots are real and equal, or the roots are imaginary or complex. First we have to consider real and unequal. In this case m1 and m2 both are not equal, m1 not equal to m2, consequently psi1 not equal to psi2. Now the Wronskian of the solution is w function of, here not multiplication, function of y2 and y1 y2. We know that it will be determinant of e to the power two solutions, e to the power m1x, e to the m2x, and its corresponding first derivative, and we found that Wronskian will be not equal to 0. If Wronskian is not equal to 0, then the linear combination of these two solutions will be the general solution of the equation. Hence as y1 and y2 are the two solutions of the equations for real and unequal roots, then its general solution will be nothing but y equal to c1 y1 plus c2 y2, or c1 e to the power m1x plus c2 e to the power m2x. So this is the two solution. These are the two solutions of equation number 2, and so it's a linear combination, because Wronskian is not equal to 0 means both are linearly independent. Okay, both are linearly independent. As both are linearly independent, they are linear combinations. That is y equal to c1 e to the m1x plus c2 e to the m2x. This is the linear combination, also be the solution of equation number 2. Now we have to consider the case 2, that is roots are real and equal. See, these are most important that you have to remember, because this will be required for your fifth semester whenever you are going to be interact with the Schrodinger equations and like that. So I suggest that you have to be either you have to remember, or you have to whatever you have to do, but these three procedures means roots, when it will be real or unequal, what will the solution, what is the Wronskian, if Wronskian will be not equal to 0, then the two solutions will be independent or dependent. So these are the basic things you should not be forget, you have to always remember. Okay, so when the roots are real and equal, that means m1 equal to m2. If m1 equal to m2, the Wronskian will be equal to 0. That means the two solutions are linearly dependent. That means the solutions are not linearly independent or linearly dependent. Let m1 equal to m2 equal to m. Now the equation 2 will be in the form of this equation. So this equation number 4. This is the equation number 4. This equation number 4. This equation number 2. This equation number 2, or this one. You can say this one. This one, or the so-called auxiliary equation, can be written, because this is two roots we found that m and m, so it can be written as d minus m into d minus m y equal to 0, and let d minus m y equal to u. So this one will be written as d minus m u equal to 0. That implies du by dx. So d is nothing but d by dx. So it will be du by dx minus mu equal to 0. So du by u equal to m dx. Integrating we get ln u equal to mx plus ln c1 and u equal to c1 e to the mx. Now d minus am y equal to u. So here what we found, here we found that d minus am y equal to u. You found that c1 e to the mx you put here. So this is the nothing but one type of linear differential equation. So how we solve the linear differential equation? We solve by considering integrating factor. So integrating factor is nothing but e to the power px. So linear differential equation is in the form of this one, dy by dx plus pxy equal to qx. So here px is the function of x or a constant, and this will be the function of x. So integrating factor will be e to the integration of px dx, p dx. Okay, and the solution is nothing but y into integrating factor is equal to integration over qx into integrating factor dx plus c. So these things we have been already studied in our first semester, and only I just recapped, recoiling you. Okay, you just recoil with yourself fastly, and then we have to move forward. Okay, so integrating factor for this one, integrating factor is how much? Integrating factor will be e to the minus or e to the power integration of p dx. Here p is nothing but minus m, so minus m dx. So integration, if we are going to consider this integration, it will be e to the minus mx. Now the solution will be y into integrating factor is equal to integration of qx is nothing but c1 e to the mx, right? c1 e to the power mx, c1 e to the power mx, c1 e to the mx into integrating factor dx plus c2. Okay, c2, that implies y into e to the minus mx is equal to c1 e to the mx into e to the minus mx dx plus c1, or we found that this one. So y equal to, we found c1x plus c2 into e to the mx. Okay, if this is the solution, if both the roots are equal. Now we have to consider both the roots are imaginary. If both the roots are imaginary, let alpha plus ib m1, alpha minus ib, let it is m2. So y will be as both are unequal, so hence its Wronskian will be not equal to 0, and they are going to be linearly independent, and the linearly, hence two linearly independent. Here I written these things at the end. Here linearly independent solution are what? This will y1 equal to e to the m1x and or equal to e to the alpha plus I beta x, and y2 will be e to the alpha minus I beta x. So these are two roots, and two roots are different. So these are the two independent solutions of the differential equation. So and hence their linear combinations also will be a solution. So hence y equal to c1 e to the alpha plus I beta into x plus c2 into e to the power alpha minus I beta x. So you can take e to the alpha x to the outside. So c1 e to the I beta x plus c2 e to the minus I beta x. So e to the I beta x can be written as cos beta x plus I sin beta x. This can be written as cos beta x minus I sin beta x. So c1 plus c2, c1 plus c2 cos beta x, c1 plus c2 cos beta x plus here I c1, here minus I c2, it can be written as I into c1 minus c2 sin beta x. So consider c1 c2 is c I c1 minus c2 as d. So this can be written as y equal to e to the alpha x into c cos beta x plus d sin beta x. Hence the two so this will be the also solution, the linear combination in the form of sine and cosine. Okay, so you just mark that the solutions whatever we are extracting for a differential equation with different cases, that those solutions are in the form of trigonometric or exponential. Okay, so now we have, if you are going to consider homogeneous nth order linear differential equation with a constant coefficient, that will be in the form of this one. So p0 dny plus p1 dn minus 1 y by dx n minus 1 and 0, or you can write dn by dxn will be dn, dn minus 1 by dx n minus 1 can be considered as capital D n minus 1. So this can be written as in this form, and so this is a quadratic equation. This is the quadratic equation can be written as in this form, because as it is a nth order, so we can found the n roots. So if n roots, that is m1 m2 m3 and mn up to mn, if they all are different, then the general solution will be nothing but the so-called linear combinations of the independent solutions. So the independent solutions will be what? y1 equal to e to the power m1x, y2 is equal to e to the power m2x, like that. And the general solution will be the linearly combination, that will be y, this is the general solution, c1 e to the power m1x plus c2 e to the power m2x plus c3, like that. So this will be the general solution if both are different, all are different. If all are same, then the general solution will be in the form of c1 e to the power mx plus c2 x e to the power mx plus c3 x square e to the power mx, like that, cn x to the power n minus 1 mx. So this will be the solution of the nth order homogeneous linear differential equation having the roots are equal. Yet we have discussed about, so what we have been discussed, you just if we are going to be a remark upon the discussions, today's discussion, what we are going to found? We are going to found one thing, that here yet we have discussed about linear homogeneous differential equations with constant coefficients. So whatever we discussed about the differential equation, they all have constant coefficient, and their solutions in the form of trigonometric and exponential and etc. Maybe it can be hyperbolic, that here we not discussed in all the things, but the differential equations having the coefficients, constant coefficients, will be in the form of trigonometric, exponential or hyperbolic, like that. However, many differential equations you can found with variable coefficients, not the constant coefficient, we will be encountered in the physics. However, many differential equations with variable coefficients we will be encountered in physics and engineering, which are cannot solved by the general method. So whenever we are going to consider the coefficients will be the variables, they could not be solved by this general method. Some of the examples I can show you. This is the differential equation, second order differential equation. See, second order differential equation, but coefficient is variable, it is not constant. This type of differential equation named as Legendre is given by mathematician Legendre. So with the naming, it is like so. So this is the form of Hermite differential equation, that will y double dash minus 2x. See, 2x is the coefficient, is the variable, y dash. Okay, like another two are Bessel differential equation, Laguerre differential equation, like that. The solution of the above equations can be obtained in term of power series. With the help of the power series, we can solve these differential equations, right? So what is the power series, and how we are going to be used, and all other things that we are going to discuss in our preceding classes. The next class we are going to discuss ordinary and singular points of differential equation. If you are going to follow your syllabus, you can find that the singular points are the important to discuss about the differential equations. Then we have to move towards towards the power series solutions of these differential equations. So thank you so much for watching this video. Today you go through this video and write down the notes May you have been written in a first semester in detail, but somewhat in a shortcut manner I have been written the note, also useful for your exam purposes. You have to write this note, and if any doubt in this today discussion, you can ask with me, discuss with me. Okay, so thank you so much.